we want to talk a little bit about how do we integrate living systems into our urban fabric. In this case, we're going to talk a lot about water and water infrastructure today, but it's just how do we actually take something that's not really supporting life right now and turning it into this living component in our urban setting. And I'm going to go back to start off, and this is the stream that I grew up in that I used to go play and build little weirs and stuff in as a kid. And I was a biologist for about 10 years out here, went back home to Ontario, and went back to this little creek to see how my fish were doing back there. And it was just chocolate brown. And this was in early September, it hadn't rained for weeks, and I'm like, what the heck is going on? And I walked up the creek and found the storm drain. You can see where all this brown water was coming out, and it's clear up above. So I then followed up the storm drain, and here what they were doing was some construction in this subdivision. And they were sucking up all this muddy water with this big truck here as they drilled, or they did something underneath driveways. And then this guy didn't know it. He just went and dumped it down the storm drain, which was directly connected to the creek. If there was any fish in that creek, they would have been dead. This project got shut down within hours after I phoned the Ministry of Environment about it. And this was when I was a biologist, and we were doing all this work in streams to create habitat. And in urban settings, you can go into a creek and you can make all this beautiful habitat, but if you don't have the water, if you don't have the watershed supporting that stream, you can't have a viable population of fish. And I think we see that in Victoria quite a bit. Bowker Creek, we don't have fish in Bowker Creek. Douglas Creek, we get fish in it, but boy, every year it's threatened with another oil spill. Colquitt's Creek, that one's got all these big buffers. It's doing well. It's got a wild population of coho salmon in it. But, I would say it's threatened because of our urban systems and our urban infrastructure that is really feeding that system. So with that, I went back to school in landscape architecture. I said, how do I go from building streams to actually working with the problem? And I think the problem is land use and how we deal with water that comes from the land that we've made this urban land, and we dump it into our creeks or in Victoria into our marine environments, the gorge, the inner harbor. So how do we do that? So one of the things we're going to talk a little bit is about sort of living and non-living systems, some definitions, the technical stuff. Then I'm just going to sort of equate that to streams and fish, and just show a bunch of example projects of how we're trying to bring life back into these systems. And then sort of, what do we have to deal with as designers and, as people thinking about, well, what are the challenges of doing this? So living systems, we've got a picture here of a cell and a nice little coho salmon, but they're open to the flow of energy and matter, and they're able to accommodate inputs and outputs. They can adapt to things. They can adapt to changes. The fish, if the water temperature goes up too much, it can go down deeper in the pool to get to cooler water. It can adapt to its environment a bit. If we think about mechanical systems, their processes are typically linear, and change can be catastrophic. Whereas in our living systems, they're able to self-organize, and change is essential to them. They can adapt to that change. We recently had a really big rain event up in Parksville. We had a few big rain events down here too. In Parksville, I think they had something like 4 inches of water in about an hour and a bit. It basically flooded out the whole town. And it was basically based on a stormwater system, a mechanical system, where there's a big change, like, wow, we got a big flood, what do we do? Oh, we can't handle it. Wow. Living systems, streams, they change. They can actually accommodate floods. They spill into their floodplains. Think about Panama Flats, when in the wintertime it turns into a lake. Well, that's the release valve for this creek. It's part of how the system works. So we've got living systems, things like animals. We've got non-living systems that are really linear and constrained. And so we want to talk a little bit about how streams, fish, landscape, how this all sort of comes together. You know, with our fish, we've got a fish that spawns in our creek. Its water is fed by the watershed, by the land around it. It needs certain types of habitats. It needs clean water, and it needs clean water for 365 days a year. You know, one day when you get an oil spill coming down Douglas Creek, there's no place for those fish to go other than the ocean. They go to the ocean, they die. They get smothered in oil, they die. You know, so what does that stream actually need in order to survive? Well, it needs clean water. And the processes that support that are basically, you know, if you think about our woodland areas and when we see it rain out in the woods, we don't see water pouring off of the land. The water actually, most of it doesn't actually hit the ground. It gets stuck up in the trees, in the needles of the trees, in the branches. It drips down, some of it drips down. It doesn't go rushing off, sheeting off the land. It actually infiltrates into the soil. And that's called interflow. And it can take months for water to actually go from that spot in an upper watershed to actually leaking out into the creek. And if you think about how creeks work, our summertime is one of the worst out here because, you know, we don't get a lot of rain in the summertime. But we still have water in our creeks, and what it is just water that's slowly leaking through the soil and making it to that creek. And it's really cold water because it's, you know, it can be 10 feet, 15 feet below ground, so it's cool down there. It's clean water, it's oxygenated, and it feeds our creeks. But when we do things to that, when we pipe that water directly into the creek, it messes it up. So, you know, we as designers, as landscape architects, we can draw really pretty pictures. We can make something look beautiful in a picture, in a diagram. We can create these beautiful stream habitats and everything else. But you know, can it actually support life? Like if we went out there and said, we want to daylight Cecilia Creek, we want to daylight, we recently were involved in a project with the city of Victoria where they wanted to daylight a creek down by Fisherman's Wharf Park. Well, if we daylight it, is it going to be a creek? Is it going to be able to support life? You know, we can draw it, we can build it, we can give it the form and function of the creek, but can it actually support it? So, you know, we have the technology, we've got all the tools to build riffles and pools. We know the geometries that they need to be, given how big their watersheds are and how much water they're going to get. But does our urban environment actually have the clean water to support them? You know, most of our urban areas are, you know, we're getting runoff off of our roofs, off of our roads. I mean, you know, my kids see this and it's sort of like, wow, isn't that pretty? And it's like, you know, this is nasty stuff that we're putting into our creeks. You know, and then do we have the natural processes to actually sustain life? You know, we can daylight creeks, we can do a lot of neat things, but, you know, in our urban setting and in our cities, do we actually have the ability to support life in a stream situation or in any kind of aquatic environment? Well, here's a typical, you know, quick and dirty look at a typical urban setting. You know, we've got development that feeds a pipe that, you know, all the runoff is going into a pipe that then gets discharged out into the ocean. A lot of our storm drain systems in the city used to be creeks, the big ones anyway, and they just go and lie down a big pipe in the bottom of the creek channel and cover it over and, you know, let's develop on top of it. Best place to put a road. And now, you know, how do we, you know, to me this is not a, you know, I know that we've been talking about resilience and I've heard the word beauty described in other aspects. To me this isn't beautiful, this isn't living, this doesn't support life, and it's ugly. And it's expensive. City of Victoria, you know, they're going to have a huge bill to try and, you know, if their infrastructure deficit is huge to try and fix some of these pipe issues that they have. These pipes can be over 100 years old now. and they're starting to fail. So we're thinking of, well, how do we actually do something different? How can we make something that, if we did something in this watershed, did a development, as a park or anything like that, how can we actually make it better and generate water that, or water from this site that could support life? I think if everyone had to take water off of their road gutter or off of the downspout and put a little fish in it and say, if the fish lives for a week, yeah, you're doing a good job. If it dies, it's not good enough. We need to be generating water off of our urban areas that can support life. So, we get challenged all the time by, we love creeks, we want to go in there and dig them up, and we want to make these beautiful streams because people love babbling brooks. But I say, sure, yeah, it can look really pretty, but if you don't have the system, if the system is still the same as we've got, it's going to be dead. You can't do it. So what we're starting to look at doing, and this has sort of been going on for the last, I'd say, 10, 15 years, maybe 20 years. But Portland's been doing this a little bit longer. Chesapeake Bay's been doing it longer still. But can we actually integrate living features, rain gardens, living soils that treat water, sort of recreating some of what these natural landscapes that we've basically obliterated by building upon them? Can we integrate those with our buildings, with our roads, so that we're at least delivering clean water to that pipe? Or, hey, wouldn't it be cool if we could build a little creek on top of the land now and turn it into a feature, into a park setting? Can we bring some of that sort of natural beauty back into our urban environment, but also have it, being viable? Producing fish, a place where your kids, you're not afraid of them to touch the water because it's contaminated. So we're looking at integrating landscape. We're looking at sort of natural processes that we're missing in our urban settings right now. And we're trying to do that in a way that we can support life in streams and life in water. So I'm going to go through a bunch of example projects that we've been working on in Victoria, and then talk a little bit more about some of the things, the issues that we're finding out there. So this is the template. This is what we want to, I wouldn't say recreate, but these are natural depression landscapes. One of these is this is up at Newcastle Island. This is a little wetland over by Woody's Lagoon. When you just see these little depressions out in the woodland areas, they fill up with water in the wintertime. They're dry in summertime. They're green. They're lush. But they're these sort of sinks for water. So water's coming off the watershed, and it gives them a place to pause. It doesn't just come rushing off the land and into the creek or into the ocean. It gives it a place to pause. We get this different plant community, different biological community there. These things are alive with frogs and insects and birds. That's kind of what we're using as our biological template, so to speak. And what we're looking at is sort of a living landscape depression. And when we do landscape, we're always looking, typically people look at landscape and they mound it up like this. We take soil in and we mound it up. Well, all our landscapes look like this. They're depressed. And so what we're trying to do is just give place for water to settle in. And unfortunately, I don't know why, but we're, all of our, you think of your house, everyone, you gotta grade your lawn so it drains perfectly, you can't have any puddles, or sidewalks, no puddles allowed, roads, no puddles allowed. It goes against the flow of what we really should be looking at doing. Giving a place for water to pause, slowly infiltrate. We take water, we put water into these landscapes, we plant them up. Plants are a significant, important part of a rain garden or one of these sort of depressed landscape areas. And that's because we get roots that go down into the soil. The soil's living, it's full of living microbes, worms, it's got different kinds of bugs growing in it, lots of bacteria. And then typically what we also do is we have a drainage system associated with it. So we're not saying, you know, just go and pour your water into the land and don't worry about it. Because you do have to worry about it. But we're working with that infrastructure. And what we're trying to do is just provide a bit of life back into it. This is just a little sketch of what a rain garden is like. And basically all it is we've got biologically active soil that we take water from buildings or roads and put into. It pools up on top, so these things actually look quite nice. Usually we get wet winters, so we have pooled water in the winter time. And that's neat from an aesthetic purpose because when you get water, it's quite a reflective surface, so it actually brightens up these areas. They're reflective, they're quite bright, really pretty, and we infiltrate our water, and it gets cleaned by all the microbes that are in there. If there's nutrients in the water, those nutrients get taken up by the plant material. We also use these because we need a fair bit of soil in our urban areas. That creates a great opportunity to plant a tree. So it starts to speak to the urban forest, and can we actually use these as a mechanism to get more soil into our downtown areas and hence then more trees. So they're doing a whole bunch of different functions. I'm going to start off going from sort of maybe the simplest to more complex in terms of land use. This is just a single family house. This is my business partner, Paul DeGreeve's house. And he's up in the Douglas watershed. And basically what he did was, this is his house right here when he first bought it. So pretty typical, you know, there's a big shrub, lots of lawn, no trees, and a big roof, and a driveway. And what he's done with it, he planted a lot of trees, but he built a little depressed rain garden right in here. And he also built 2 cisterns. So he took the water, it all flows in one direction here, and he put in, so it goes through 2 cisterns, which he uses to water his veggie bed for the summer, or part of the summer anyway. But in the wintertime, the cistern is connected to this bowl in his rain garden. So it acts like a water feature. And when it rains, this tank fills up with water. And you can imagine as that fills up, and he's got it connected to an outlet down below, there's pressure that pushes the water out. So he ends up with this nice little water feature every time it rains. And it's a slow delivery system. This is quite much like an engineered system. We often put tanks in the ground that has a hole in it that goes to the drain, and this is a standard practice in Saanich and all the municipalities of how we deal with water. But this is elegant. This is fun. This is like, you know, this is a free water feature every time it rains. And but it's doing the same thing as slowly delivering that water. He's doing one better by putting it into a rain garden, which slowly leaks away that water, cleans that water before it hits a drain and goes into the storm drain system. And in fact, I don't think he has a drain. I think his soils are pretty porous. He's not seeing water actually leave in a drainage system. So that's one. This is the Yarrow Rain Gardens, and it's right near the gorge. Here's the gorge waterway. This is the Craigflower Bridge that's being reconstructed right now. And what we did was, this was a city lot that the municipality got. This is the Esquimalt. When this subdivision was redeveloped, this was their piece of land that they got for an exchange as parkland, I guess. And when we redid the streetscape on, this is Craigflower Road, we basically took all the water, piped it in through here, and then let it go into a series of rain gardens. And so you can see there's the pipe coming in here, and it goes through a rain garden and weirs and spills and goes down until, if it overflows, it actually can overflow into the gorge. But I've never seen it actually overflow. We have an underdrain in it, and it slowly just leaks away into that. But you can see when it's full, I mean, it's quite an interesting landscape. There's a lot of diversity here. We planted about 20 or 30 baby Gary oaks that are now, you know, these were about this big. They're up this big now, which is pretty good for Gary oaks. You know, they're slow growing. But it's went from basically a lawn, a lot that was a lawn, to a water type landscape. And I would suggest that it's actually helped improve the value of some of the houses around it. None of them have sold, or you know, it's too small to know, but it's quite a pretty landscape to look at. Here's another example. We do a lot of work with streets and with municipalities. This was the first rain garden that the city of Victoria actually built on one of their roads down on Trent Street. It's right near the Trent Street pump station and St. Joseph's School there at the end of the road. But this was before, or St. Patrick's School, sorry. So Trent Street, this is Fort Street here. Trent Street dead ends. This is Victoria. There's a line here. This is Victoria. This is Saanich. So initially we wanted to put our rain garden right there, but Saanich wouldn't let Victoria put the rain garden in. So couldn't do that. But this is the street before it was done. And you can see it had sidewalks that came right beside the road on both sides. It had lots of lawn. And this school, so all these kids, and people would drop their kids off all over the place. It was a real problem. Kids were going all over, and cars were coming and going. And it was a bit scary, actually. So when we designed this, what we tried to do is develop something where, hey, can we take the sidewalk off of the road and give us some land that we can actually turn into a, you know, do something with. And then instead of the gutter continuing down, there's the storm drain that goes to, this goes to Bowder Creek. We just put an inlet here, we take all the water into this big rain garden. We did this on both sides of the road. So we were able to separate those sidewalks, so we take the kids away from the cars. We narrowed the road, which was 8.5, we narrowed it down to 6. So now parents can't park where the school didn't want them to park, because if they park there, they block the road and people get really mad. So that solved that problem for the school. We think it's a really good educational opportunity for the school. The kids get to see how water comes off the street. It's pretty dirty water when it goes in there. It's very clean when it comes out. This particular project is being monitored right now by CMHC. They're monitoring about 10 rain gardens across Canada, and this is one of them. And so far, we're hearing very good results in terms of how it's functioning. But aesthetically, it's you know, we planted 6 trees here where there used to be none. You know, so I think that urban forestry component is key. Here's another one where this was on Cecilia Road, just up from, just opposite where the Burnside Village Community Community Center is. It's just across the gorge, or across the ravine from them. But with this one, we were challenged with, it's a road ending and the city is looking to do a plaza. And, you know, could we do something with it, with developing a rain garden, but also incorporate, you know, how does that fit in with the park setting? This is a playground over here. So we take the water, goes into one rain garden, goes underneath the sidewalk into a series of cells, gets cleaned. But it's also really quite beautiful. You know, we can play with landform. We can play with how water moves across it. It's this beautiful landscape that, you know, you can sit on the walls, watch your kids play while water is being cleaned behind you. Atrium building downtown. Again, here it is within its watershed. Basically, there's nothing green, or very little green in that watershed. But, you know, here's a green roof managing rooftop runoff. And rain gardens and rain planters that were taking water off of the roadway, cleaning it, and managing that runoff before it went down into the gorge through the typical drain system. Which just sort of shows how it works. Just a series of depressions, series of planters that we've incorporated into a typical streetscape design. And again, you know, creates great places for people, separated sidewalk, separated people from the roads, cleans the water. We figured there's about 100 meters of seeding wall there. And we've got a minimum of 7 cubic meters of soil per tree for planting, which is pretty significant in urban setting. And the thing is that if we can go from one site, this is incremental. I mean, this urban environment, it's taken 150 years to build. So if we think about like a 50, 60-year time frame, can we start to make this more and more green as we go? I mean, I think if we did that, we'd end up with a fairly more livable system. This is the last project. This is Fisherman's Wharf Park, City of Victoria. It's down right at Fisherman's Wharf Park. And this is this drainage basin here, all the way back up into Beacon Hill. There used to, we think there used to be a little stream that came up in here, some wetlands and other types of landscapes. It changed, the watershed changed. When storm drains go in, they cut off different parts of the system. They pipe water over to different areas, so it has changed in time. But the biggest change was that this used to be the old shoreline edge here, and in the 50s it got filled into the level of land that you see now. So what we looked at was there was a big storm drain coming down that whole, draining that whole watershed, and what we wanted to do was intercept that pipe, and instead of daylighting the creek, or the big pipe, we daylighted 2 pipes that were only about 3 meters deep, and we diverted those into a large rain garden. So we are actually cleaning. Here you can sort of see this is the main pipe way down deep. We ended up daylighting a couple of pipes up higher, and there was a lot of reasons for doing that, but the biggest one was there's a lot of contaminated soil that we didn't want to get into, because then what do you do with it? The other part of it was that this water that comes out of this big pipe is pretty dirty water, even though it's going through a big storm scepter type of system. It's got a lot of bacteria, it's pretty skanky water, and you can see the type of landscape that we were able to create down below. And there's the big thing, is that we were able to manage in the park about a fifth of the watershed's sort of stormwater coming off of the roads and buildings, and a fifth of the watershed, which is, I think, pretty significant. Just a quick rundown on some of the threats and risks that we have to deal with when thinking about this. Challenges, structures versus process. Easy, everyone wants to build in creeks, but we really need to think about the processes that are important, like infiltration, like how groundwater interacts with streams, trying to disconnect those pipes, and instead of using pipes just to throw water into creeks, how do we get that natural process back in there? Engineered stability versus sustainable change. We often are challenged by things have to be static, something can't change, and we really need things that will change and that are dynamic and that are resilient. Rain gardens are resilient. We get a little bit of oil in them, bacteria can decompose it. Get a bit of oil in a storm scepter or something else, and the next rain event that comes along flushes it out. So, we're trying to build in some resilience into that without armoring it up, without making it totally bomb-proof. Challenges, integrating processes that support living things with regulations that want measured certainty and no change. So, our municipal bylaws can be very hard to work with in doing this. An engineer can size a tank, and he can put a hole at the end of the tank, and we know how much water is going to come out that hole. A rain garden, we can put water in it, but we don't know how much water is leaking into the ground around it, and some of these other variables. It's not as measurable, so it's harder for them to do. It makes it more challenging, and a lot of times we get the, we can't do that kind of thing. I can't calculate that, so therefore we can't do it. So that's a challenge that we really need to push forward at the municipal level, I think, the regulatory level. And then the rewards. I think the rewards speak for themselves. I think healthy communities and habitat, sustainability, taking stormwater, which everyone thinks of as a waste product, and making it into something that's elegant and beautiful. We want places where, to create places where people want to live. I think people want to live in places that are alive. And I think, I think that we can have lively urbs in these types of landscapes and systems. They're not just based on, they're not a one-dimensional, one-value system. There's a lot going for them. Living in infrastructure continuum, with pristine streams as the most alive to, I'd say, storm drains are about as dead as you can get. We think that by using these types of landscapes, we're sort of pushing our water systems and our urban water more into that living end of the continuum. And with that, let's leave you with that quote from Bruce Ferguson, landscape architect in Georgia. But Bruce has been doing a lot of permeable pavements and different types of things like that. So, yeah, thank you very much.